Okay. Here we are. We're going to talk about Sagemaker. Let's get to it. All right. So what is Sagemaker? Mohammed, I agree. It's cool to be in Oregon. I have friends in Oregon. So note that it is what it says it is. It's basically, it's a bunch of services. So it's kind of a meta service actually, and it can be used to build, train, and deploy models. And, just to show you this, if you haven't been in it before, if really I haven't been in SageMaker recently, that doesn't make any sense. If we go into SageMaker as a service, I just want to point out, first of all, there are different kind of studios that you can use. There's also, by the way, a labeling aspect to SageMaker. You can run notebook instances, which allow you to run Jupyter notebooks. You can do all kinds of like pre-processing jobs, processing jobs, training jobs, including hyperparameter tuning jobs. You can run inferences, right? So this includes like the deployment, like the production deployment of models into endpoints, which you can then subsequently either use on demand or batch. You can push some ML to the edge, depending on whether you're using Neo or some other kind of optimizer for like edge IoT devices. And then augmented AI basically allows you to supplement basically machine learning based tagging and labeling with human workforce management, which Ground Truth will do as well. And then there's a marketplace where you can actually look at third parties and just grab a bunch of third party services all related to ML, which include companies that are pretty well known, like that do like data processing, like Databricks as an example, which is mainly more EMR focused, but has some impacts here, and or other more secure third parties that you might have a contract with in order to have like private labeling for sensitive data, or other algorithms or other models or pre-trained models or pre-trained embeddings. So just know that the marketplace is a powerful place to get third-party material. Please be aware that you need to know the vendor and have a relationship with them outside of Amazon in order to meet whatever legal and compliance guarantees you need for your business. Okay. So just keep that in mind. We're really only going to talk primarily about basically variations of inferences, but mainly training and notebook is where we're going to spend most of our time. We're going to like briefly touch on ground truth, but it really is actually going to be training, and notebook is where you're going to spend a lot of your time. Now, most of us, by the way, are in Jupyter notebooks. We're not actually in the console. You're just using the different like software development kits to interact with SageMaker. So, but just know that the console is probably the easiest way to visually learn and manipulate SageMaker without having to mess with a whole lot of code. So, am I expecting you to remember all that just from one little showcase? No, of course not. There's more to talk about. Not at all. Okay, so you remember this. This is our pipeline. So considering this pipeline for a minute, we talked about several phases, right? Which includes, the softer kind of business problem formulation, and then all of the harder stuff, right? Where you're going to collect the data, visualize it, modify it, train with it, tune with it, evaluate the model, then deploy it, right? So SageMaker fits around all of that, except for obviously the business problem. And is this an ML problem, and what kind of ML problem is it? So it helps manage a lot of this complexity. So instead of you having to roll your own or call it out in Scikit and then kick it out to a production level system and then scale the system and do some kind of distributed consensus, none of that. I do a lot of that for teams, especially around Kubernetes and a lot of like ML workbenches or Airflow workflows, that kind of thing. Yeah, you don't need to do any of that here. SageMaker really is more of a SaaS than it is a PaaS, although, well, it's kind of passy sassy because it does actually deploy virtual machines, but you just don't really manage them. But this is where SageMaker fits, is it does all of this and not the business problem, ML problem formulation. Be clear that we're not going to cover every nook and cranny of like right now, but we are just trying to get you started as a primer on what SageMaker could do, right? Now, we are going to be working in Jupyter notebooks where you basically can create and share your various documents. You can code in those documents. You can run reports and visualizations, analyze your data, explore the whole thing. Notebooks also, by the way, function off these things called frameworks like PyTorch and MXNet and Chainer, et cetera, right? And these, these are really just interfaces to the frameworks themselves are just like interfaces to like these pre-built kind of libraries and components for conducting your ML work inside the notebook. Kind of a little bit like interacting with Mac and Windows. You don't have to manually interact with the hardware. Mac OS and Windows can like do that for you, right? So for our projects, we're going to be using Sagemaker and all of its built-in algorithms. But I want to be clear about this. You could bring your own framework. You can bring your own frameworks to your own algos, your own algorithms to Sagemaker if you want to. Now, Sagemaker runs instances which are called virtual machines. Instances, virtual machines, same thing, right? So when you spin up a notebook instance, you are spinning up a virtual machine that has certain processor, memory, and disk characteristics. This is fully managed by AWS. You do not get a login to the operating system. So AWS is going to manage the creation of the instance and any of the related resources like disks and networking and whatnot. So all you have to worry about is launching the instance and using it. That's it. You don't have to sit there and manage the whole thing. It's not the purpose of why we use SageMaker. That's not why we're here. Okay. Now, you might say, Michael, what kind of instance can I launch? Well, oddly enough, you can launch a lot of instances. I will tell you that first of all, you're not really going to be tested on the specific details of the instances. You're not going to have to do that, okay? But that being said, with a notebook instance that you're just running training on, you do have to pick a size. And what kind of training? So let me throw this out there. If you're doing deep learning with, any kind of neural network, let me ask you this question, because maybe some of you already know this. Are you going to be emphasizing CPUs or GPUs if you really want to squeeze the juice out of that? Yeah. You may wonder where all the GPUs have gone. It isn't just, by the way, for altcoin. So just so we're clear, people don't use GPUs for Bitcoin mining because, quite frankly, it's super inefficient. They use ASICs for that. But if you're like into, I don't know, Solana or Ripple or any of the altcoins, Ethereum, those are all using GPUs because GPUs are better at I'm going to pick on something specific at hash calculations. They're faster for the price point than CPUs are, right? They're faster at it, right? They don't have the complex instruction set. And so if all you want to do is run some hashes, GPUs are better at certain types of number crunching. They're just faster. They're lighter. They don't have all the complexity. That's what they're there for. So the reason I mention that is that the T family, the M family, the R family, and the C family, so everything from C to the left does not have GPUs attached to it, but the P's and the G's, you can actually get GPUs inside of the operating system, which is something you can access and then use for your calculations, especially if it's deep learning, right? Now, here's the tricky part. I'm going to draw on this just a little bit because I want to make sure I'm being very clear about what I'm saying. All this stuff right here doesn't have GPUs. These items here, they do have GPUs attached to them. And the thing in yellow that I'm about to now reinforce, right, several times over, that, wait, are you guys not seeing what I'm seeing? Hold on one second. Oh, okay. I was sort of weirded out there for a second. You guys can't see what I'm showing. I've been talking the entire time and nobody can see anything. Got it. All right, cool. All right. So yeah, it sometimes takes some, a couple seconds, maybe longer for it to show up. So what's important about this is that you do need to know in general, because remember, they're going to assume that you have an architect's level knowledge of AWS, is that the T family is the general purpose along with the M family, which stands for median, right? So the T's and the M's are general purpose systems. I actually use T's for testing, just so we're clear, because they are the cheapest systems you can get for the processor and memory, and they're really good for proof of concepts. So if you're going to muck around in AWS, please use the T series. They're going to cost you somewhere between like 13 and 50 cents an hour. They're great for proof of concept. The M, the R, and the C family are all like designed around certain characteristics. So for example, the M family has a standard CPU to memory ratio, 4:1. So for every processor, you get 4 gigs of memory. The R family is an 8:1, meaning you get 8 gigs of memory for every processor. And the C family is 2:1, which not only that, the C family has specialized like real like Xeon processors, so not highly abstracted. And so the compute optimized instances are going to give you raw processing power at a 2:1 ratio to memory. You might say, Michael, how do you know all this? Well, this is what they cover in the architecting class. And you don't need to be able to rattle off that there's a C6, a C5, and a C4, or an R6, R5. You don't need to rattle all that off, or that the T2s and T3s are preferred. You don't need to rattle that off. Here's what you do need to know. You need to know 2 things. One, assuming that Michael can clear off all of his little squiggly lines, how would you find information about the instances? Well, here's where you go. So if you go to ec2instances.info, also renamed to instances.vantage.shy, somebody bought the domain name. This will allow you, let me just clear all the filters here. This will allow you to do things like find out what the ML instance sizes are based on their names. What do I mean by that? If we come out here and look at Sagemaker instance types, which is also could be under pricing. And this is Sagemaker Studio, so anyway, it didn't matter. We can look at this. Notice that these start with MLT3, MLM5. Let me blow this up a little bit. M5 16x large. Here's the C series, which is the C5s, right? And then all of a sudden we get into the P series and the G series. You're like, Michael, how do I actually know how much processor and memory is there? You're going to go to the website link that I just gave you. And let's say someone says, hey, let's use the C5 2x large. And you can come out here and you can actually search for a C5 2x large under API name. And it'll tell you that it's 16 gigs and 8 CPUs. Do not try and memorize all these sizes. And notice their t-shirt size. So there's a 2x large. There's a standard X large. There's a large. Notice that, by the way, it doubles, right? Right? Notice that, you know, an extra large is double, 2x large. Anyway, you get it, right? So if I was like, hey, someone comes to you and says, you know what, I really want to use a T3 medium to host this notebook that I'm messing around with. First of all, you got to spell medium correctly. That'll tell you instantly that's a 4 gig system with 2 virtual CPUs. It doesn't have any GPUs on it. And it's going to cost you on demand about 0.041 cents an hour. By the way, they charge by the second unless you're using a licensed operating system. So you could literally start it for 30 seconds and stop it as long as you're not using SUSE or Red Hat. Right? Which, by the way, if you use SageMaker, it just uses Amazon Linux by default. So just roll with that. Don't worry about it. It's a RHEL clone. Okay, for those of you who are interested. So notice that, by the way, for little more than 4 cents an hour, you're going to get a 2 processor system with 4 gigs of RAM. So this allows you, by the way, to compare what's in the SageMaker documentation and actually find the system in question. Now, this is okay, but what if you need more like detailed information about these instance types? Just to throw this out there. Here's what you can do. You can type in EC2 instance types. And I'm going to paste these links, by the way. So this is the SageMaker instance types. And then here's the EC2 instance types. You're going to want to look at the EC2 instance types if you really want this information, because as an example, notice how it says P3 8x large, right? Okay, awesome. P3 8x large. That's what we're looking at. How do I then get to understanding exactly how many GPUs and whatnot does a P3 8X large actually have? Well, here's how you do that. So what you would do is you would come over here, and since you know the P, like the P in the G series is accelerated computing. How do you know that? Well, because I told you. You're going to come in here and you're going to look for the P3 series, and then you're going to scroll down and look at the 8X large. And this is going to tell you that it's a 4 GPU, 32 processor, 244 gigabyte of memory box with 64 gigs of GPU memory. The P2P for it is an NVLink, NVIDIA Link. And then you have to use EBS storage. You get 7 gigabits of bandwidth for the disk. You get 10 gigabits of bandwidth for the networking. Now, in general, are you going to care about this? You need more horsepower from a parallel, like from a standpoint to train. Usually when you launch in production, you're going to use auto scaling to horizontally scale because your model's already going to be trained at that point. So to answer the earlier question I saw, does this handle auto scaling? You don't typically do auto scaling for notebook instances for training, but when you deploy it out into production, you can actually have it set so that you can have multiple instances set up on the behind a single endpoint, so that you can actually have scale if you need it. Okay, so you can just add additional instances. Does auto scaling work natively with Sagemaker just yet? Not quite. It'll get there. It's not there yet. But this should allow you, between EC2 instances.info, the Sagemaker instance types, and the EC2 instance types, this will allow you to be able to figure out exactly what horsepower you need. In general, if you're just messing around, then use the general purpose boxes, and I want you to use the T3s. And you might say, well, Michael, how come we're not using the T4s? Because you said the latest generation was awesome and cheaper and faster. You should stick with that. The main reason is because the G stands for Gravitron, which is an ARM-based processor. Not everybody's tooling is up for ARM yet. Amazon's kind of pushing that down, pushing that ahead of everybody's like readiness. So just know that you might stick with the T3s because they're Intel-based, they're x64-based processors. How big can you go on the Ts? Well, if you need 8 virtual CPUs and 32 gigs of memory, right, you can get that. Just a word of note is that you would not deploy the Ts into production because they do actually have what's called CPU limitations or credits. So they'll only run at 100% for a certain period of time. You can make them unlimited if you're willing to pay for it, but if you're going to do that, just go ahead and use another instance at this point. Okay. So these are the EC2 instance types. So if you want to see all the available SageMaker types, by the way, in the SageMaker documentation, the developer guide as well, you'll find it. Okay. I feel like a lot of information. Good. Oh, you might, by the way, if you needed to find out, you just saw, by the way, with the P family, how to find the number of like GPUs you got. So if like, for example, that P3 8X large had 4 GPUs and 64 gigs of total memory. The other thing that throws you off a little bit is that this elastic inference piece is actually a set of GPUs that can be attached to any of the family types. So you don't just have to go after one of the more expensive P and G family types. Like adding a disk, you can actually attach video cards to any of the T's, the M's, the R's, and the C's that are here to give them GPU capability, even though they're not in the P and the G family. So elastic inference will actually allow you to attach GPUs to one of the like other boxes that don't traditionally have GPUs. I'm going to give you the documentation link on this, right? But this basically allows you to dynamically attach them as needed. So it's actually really cool. And you can actually attach them to containers as well, or to SageMaker instances. So I put this link out here for elastic inference, but it basically makes it so that you don't have to have a standalone kind of like GPU instance. You can just attach GPUs as needed to the instance in question. No code changes, right? So then you can use the CPU configuration that's best for you. And then if when you need GPUs, bring them in. And when you don't, you can take them off, right? So it's pretty flexible. There's the supported frameworks, but probably already knew that. Okay. How would you know how much memory do you need? Well, that depends. Like, for example, sometimes you have to fit the data set in memory if you're trying to go for like certain kind of algorithms. And so that would dictate how much you need. Obviously, if that isn't the case, you might just end up making some guesses, Mohammed, over time to see. And what you really need to do is that for the model that you're training and the data, you just need to look at the CloudWatch performance metrics and see if you're getting like out of memory errors or some kind of thrashing. That might also like dictate where you go. But that's just something that you pick up when you're working with a model and a data set over time. You kind of start to figure out whether you're it is definitely trial and error, right? There are like formulas that can give you kind of a general rule of thumb. But just to say this, Mohammed, if you go out and prune a data set out of it because you were trying to condense, correlation, right? And so you can drop it, or let's say you decided to find the commonalities and condense it, like using PCA or whatever, that could radically change your performance profile, right? And so the general rule of thumb, and I know my ML people will probably love me saying this, is I try to give the ML people the biggest, baddest box that I can for the specific period that they're doing training. Because if that model trains faster, guess what? I get the results faster. They get business results faster. That's what we're trying to do. So, but it is trial and error, right? You really just don't know because there's such a mix of how the algorithms with data sets, and depending on the dimensionality of the data set, will perform. So Thomas, that's a good question. You said, it's my understanding that elastic inference is cheaper than using a dedicated GPU. Why does AWS allow that? How does that help them from a monetary perspective? Well, Thomas, if you're more likely to use them because one, you can't buy GPUs, or two, because they're making it easier for you to do machine learning on their environment. Remember, convenience is king. I don't know when this flipped. I think it was 2018. But when we were profiling consumers the world over, it was now that convenience trumped price every single time. For example, Amazon, like for like basic necessities like shampoos and stuff like that, is usually 4 times the price of, say, like Walmart. But just to say this, right? If we just order it online and it just shows up auto shipped and ready to go at our front door, and all we need to do is tell Alexa, hey, sorry, Alexa, cancel. Not talking to you. Then guess what? That's convenience that's totally worth the price, right? And so people can't beat that. Yeah. So, but I don't know the full reasoning other than they're trying to eat all of your operational costs. Amazon wins by basically trying to get you to give them all of your operational responsibility. That's what they want. They want to make it as easy as possible for you to run your business, and they want to take everything that's not core to your business. They want you to give it to them at a fair price point, which I think is true. Good. Good questions. Thank you. Okay. All right. So Sagemaker, you're going to choose your instance notebook. Think about pricing. Someone the other day was like, hey, they only charge you when you're actually doing training. That's not true, actually. Not you guys. I heard somebody else say it. So if you've started an instance, then you're going to pay for that instance for as long as that instance is running. If you stop the instance, then you don't pay for the instance. But if you start it and you've asked for capacity and you ask for a 4 CPU, 16 gigabyte machine, you're going to pay for that virtual machine for as long as it's running for. Now, if you stop it, you're not going to pay for anything but the storage, because that's way cheaper than compute. But just to say this, if you ask for capacity from Amazon, they're going to start charging you. So now, is it going to be $1 an hour? No, not unless you get one of the big systems. But in general, it's going to be, somewhere between fractions of a penny to, up to $2, $3 an hour, depending on the huge size of system you get. But most of us are going to end up paying about 10 to 25 cents an hour for a box that we can use. So yeah, again, reminder, when you're hosting a notebook instance, you pay for it the entire time that instance is running. You can stop instances without deleting the instance. Your data is still there, it just powered off, right? You didn't terminate it. So just keep that in mind. You may remember earlier I showed you that there's a couple of different services underneath SageMaker. Ground Truth is one of them, right? You know, after you got your notebook set up and you begin processing your data, you might realize that you need to create a workable data set, right? So after you've collected and prepared your data, SageMaker can help you create your data set either through unsupervised learning, or you can get access to human beings who will label the data for you. Now, just to say this is that you can either use Mechanical Turk, which is Amazon's like human workforce of people to label your data. You can use your own private workforce, meaning you could create a ground truth job and have it sent to your own private workforce to keep things super private, especially if it's sensitive information. Or you could hire a third-party workforce from the marketplace who might also have security compliances and other things for your data. And, you know, that might work really well. My recommendation is that if you can just use Mechanical Turk, if it's not sensitive data, then just do that, right? The data is going to be spread all over the place. So it's not like any one person's going to see the whole collection. It's going to be really hard. If your data is sensitive, then my recommendation is go get a third party. Go get a third party, go find out who offers third party on AWS, go sign a contract with them, get an NDA in place, get the legal teams to look at all that, and just establish them as a vendor that you can use with ground truth in the marketplace. Some of the people out there have incredible levels of security clearance and classification. It might take a while because it's got to go through all the legal teams. But if you don't want to use your own private workforce, my recommendation is go find a third party who offers secure, like security certified levels of labeling, right? Security certified, that sounds weird. It offers labelers that meet a certain security standard. Now, in general, by the way, ground truth will try and add labels when it has a super high level of certainty around it. And then ambiguous data is going to go back to the human labelers who are going to model it. Oh, Joel, that's good to hear, actually. Yeah. Yeah. Good. Yeah. Again, if it's sensitive, probably keep it in-house. Go to a third party if you need to. If it's not sensitive, then use Mechanical Turk. Do note that after you set up your notebook, you can actually kick out visualizations inside the notebook. Yes, Darshay. If you have an unlabeled data set, what will happen is that they can put labels on it for you. Yeah. When we get to the pre-processing, actually, I'll show you how to kick off a job. It is remarkably underwhelming. There's nothing like super significant about kicking off a job. It's remarkably underwhelming to kick off. It just outputs everything into an S3 bucket is your labeled data set. So just know that, you know, if you want to look at this, you want to look at like visualizations inside your Jupyter notebook, you can. Obviously, visualizations are important, especially to find outliers or trends or symmetry and asymmetry or skew in the data, right? So that you can help and see those patterns. Obviously, be aware that machines are going to see data patterns in a way that's like much deeper than we can. But in general, human beings have a better kind of en masse way of seeing patterns at a highly abstracted level, not a detailed level, than most computers do. If you want to use SageMaker to do your model building, training, hosting, etc., just know that you can use SageMaker's built-in algorithms, of which I believe there are 17. And you can write a script in your own framework. You can get an algorithm from the AWS marketplace, or you can bring your own algorithm. So bottom line, by the way, is if you make any changes to the frameworks, like you want to use a different framework, or you want to make major changes to like PyTorch or MXNet or TensorFlow or whatever, you're going to have to build, just so we're clear, your own Docker container to host that framework, because everything inside the SageMaker virtual machine works off containers. Now, I know some of you are not familiar with containers, so I have a video that's going to go in the video playlist that talks about how containers are really just process virtualization, process isolation. It's application virtualization. And so if you're not familiar with containers, which I think most data scientists are at this point, because that's usually how models are kicked out and deployed, you want to get familiar with containers as quickly as possible, because I don't know of a single ML team that I've talked to in the last 3 years that isn't using containers. So just enough to know how to build a container and know how to like kick it out. That's all you need to know, right? So I have a video, by the way, that talks about how to build containers and what container orchestrators are. That video is going to go into your playlist. I probably forgot to mention this, but by the time you leave on Thursday, you are going to have a YouTube playlist that is going to include all the recordings by module, including all the test prep sessions, including the container thing that I just talked about. So you're going to have a recording of every single thing that we've covered in class, other than logistics, which we didn't really record. So, okay. All right. Once you have your model trained and you figured all that out, right? I mentioned this before, and I think this was on like the assessment test, is that you can generate one prediction at a time on demand, meaning you kick out a data point in, and then it kicks back a prediction, or you can do a bunch of data set, like a data set, not a data point, bunch of data points, a data set, and it will give you back a bunch of predictions all at once. Okay. So online and batch are typically, or on demand is how that's referred to. Okay. All right, hold on. Let's walk through this really quick. All right, so let's go into SageMaker. Let's go into notebook instances. Do I have one running? Oh God, I do have one running. Why did? Oh, I was messing around with ground truth. That's right. I was doing it. I was messing around with a tutorial. By the way, they have an example in the labs. Sorry, in your in your student guide, where they're like, "Hey, click on this link if you want to run a ground truth tutorial." I just want to forewarn you that the last time I ran that tutorial, which I was actually just looking at again last week, it was $120 to run that tutorial. I know that all of you are millionaires and you have invested heavily in altcoins and NFTs and stuff, and so you're all rolling in the money. I would probably maybe not do that tutorial. Just it's not even worth $120. I don't even know. I wouldn't do that. Okay, so let's say you come in here and you're like, Michael, I want to start a notebook instance, right? So you just well, maybe I should start at the beginning. Let's go to console home. So when you log in, the first thing that's going to happen is that you're going to end up in the console home. It's going to look like this. Now, it just so happens I have SageMaker there because I was just there. What you can do is you could click on services and like click on the section that you wanted, such as machine learning, right? I got to tell you, that's a really painful way to do it. Instead, I would go up here and type in SageMaker. And then click on SageMaker. That will take you to SageMaker. And then, you know, I think the marketplace is listed at the top. I'm not going to open my SageMaker domain. In this case, see how it says notebook on the left-hand side? I'm going to open that up. I'm going to click on notebook instances. Now, you saw that I just had one running. Let me blow this up a little bit. Oof, that's already big. Actually, let's leave that alone. Then I'm going to click on create notebook instance. Now, in this particular case, I'm going to create a notebook instance, and why don't we just give it an instance name? As far as like it being an M2 medium or blah, 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 right? Just know if you click on this, this is where it lists all the instance types. Note that it does list them out by compute optimized, memory optimized. Anything that says accelerate computing has GPUs attached to it. So for giggles, let's just do a T32X large. Notice that I can add GPUs to the system. You're gonna have to look those up if you want to know the sizes of those particular things, right? We could look up here to, you know, look at the sizes and all this stuff, right? how to attach it. Documentation's right there. In this case, I'm not actually going to use any Elastic Inference. I would tell you, by the way, in general, if you're running your notebooks, try to use Amazon Linux 2. They are getting rid of support for Amazon Linux 1, right? So try to run 2. Under additional configuration, you can do things like create a new lifecycle configuration, or set up whatever like makes sense here. Lifecycle configuration, by the way, will allow you to configure what the notebook instance does when it boots. Do you want to do pip install? Do you need to like massage frameworks? Do you need to download data sets? Whatever you need to do there, that's what it does. Notice, by the way, that it is actually going to use some kind of role to control permissions. Roles are security like permission sets that a service can assume in order to be able to execute and talk to other services. You can give a user's root access to the notebook, or you can disable that. You can add encryption if you want to. You can do things like put it inside of a VPC. You can download Git repositories, right? So you can clone a public Git repository or add a repository, right? If you want to. And if there's any tagging like, hey, this is owned by Michael Forrester. Here's my phone number. Here's my email address. You can do stuff like that if you're in a shared environment. So once you answer a few questions, including picking the size of instance you want, you can really just come down here and just create notebook instance. And then what it will do is you'll see it go into pending, right? And then it'll basically like move towards like until it's in service. If you need to see more, you can click into it and see what it's up to. Notice I can't really do anything until it kind of like reaches a certain level of maturity as far as deployment. If I go and click on the other one, the ground truth tutorial, notice that it's fully populated, including any kind of other permissions and anything else that I've set. Notice I can stop it. I can open Jupyter. I can open Jupyter Labs. So let's say I'm in this one. Let's just say I want to open Jupyter, right?
Hey, Michael, real quick.
Yeah.
We're at this point, we're just using our own like AWS accounts. We don't have like a specific account that we are supposed to be logged into or using. I might have missed that earlier.
No, I mean, this is really just a demo to show you what it looks like.
Yep.
Yeah.
Cool.
The labs, you're going to have an account that's created for you by Quick Labs in AWS.
Perfect. Okay.
You only need your own account if you want to do anything outside of the class later on.
Yeah. Cool. Just making sure.
Yeah. So, okay. So here we are. We're like, this looks good. Now, notice I don't have any like terminals or notebooks running. I don't have any clusters, right? Which is a whole different conversation. Let's say that, I'm like over here, and by the way, there's a bunch of options, like a bunch of options. So like, for example, if we wanted to create a training job, or we wanted to learn about hyperparameters or whatnot, just to give you an example, let's use this really quick. While that's loading up. So just notice there's a bunch of things like use cases, like data set preps and whatnot. If you wanted to look like end-to-end projects, like you wanted to do like model monitoring or auto claim fraud detection, there's just a bunch in here. It's really awesome. Please save this for after class, because people get down these rabbit holes and start asking questions. I'm not going to answer any questions about the examples, just because it goes way far down and usually outside what we need to talk about. Data prep, ground truth labeling jobs. There's like, there's a lot here, right? How to ingest data, lots of stuff. So let's say that couldn't really find one that matches Python 3. Really? That's interesting. Okay, so in that case, I just did set conda for that, anaconda. So here, by the way, like notice that this is a markup cell. So what this is like, if you double click on this, by the way, you can actually see the markup that is behind this cell, right? So you can actually see what's going on. So you can see here, by the way, they just have a little pound up here, how they created these bulleted lists, those kind of things, how they create active URLs. Notice that down here, By the way, I just hit Shift Enter, which just basically ran the whole thing. Notice that down here, we're into code, right? Now, notice that if I run this, every time I run this, it goes into a star when it's running. And then when I run it again, it's going to increment the number every time. Please be very careful when you go into the labs about running things out of order, especially when you are deleting and pruning data sets, right? Because remember, these are procedural. Sorry, Nicholas, I saw your question. Hold on just one second. These are procedural, which means that if you do them out of order, make sure you know what you're doing, because if you try to run a visualization, which was step 2, and you deleted some of the columns in step 5, and you go back to step 2 to rerun it, guess what's going to happen? It's going to throw an error, right? So don't just haphazard, by the way, just click through these things. Make sure you understand what it does, because you might need to modify your visualization if you deleted columns in the next set, especially if you're calling out specific columns. Okay. So Nicholas, you were asking, you said, will we use SageMaker Studio to create notebook instances? If not, when is that appropriate? So here's what I would tell you, Nicholas. One, in the labs, you are not going to use SageMaker Studio. I wish we were, because I got to tell you, things are much easier to do inside of SageMaker Studio, but they wanted you to have the raw experience of manipulating and managing, because you're going to ask me questions like, I'm just going to speculate for a second. You're gonna ask me questions like, well, how do I see how my model's doing in real time? And my answer is going to be, well, if you were in Studio, you could run a TensorFlow board and you can see what's going on, and right, that's going to be my questions for you. And we're not doing that, because the Quick Lab is a primer, and they want you to do a little bit of raw so you can see how that works. But I will tell you, when is that appropriate? When is using SageMaker Studio appropriate? When is using any ML Studio appropriate? The answer is all the time. That's the answer. I think using any kind of ML workbench, any kind of ML like studio of any type is always appropriate. It's like using an IDE. When is it appropriate to use an IDE? Anytime you have access to one. So I say go for it. By the way, if you need to import other things, or you want to print something, for example, obviously there's lots of different syntactical ways to do it. Like if you wanted to print something, you could do whatever you wanted to, right? And anyway, that's not going to print just because of the way it's doing the function call. But my point being is that you can put any code in here that you want to. By the way, don't forget, double click will let you see the markup if you want it, right? By the way, here is where they're escaping to bash. If you put like an exclamation point in front of a command, by the way, it's going to run it right out of the command line. So if you want to run something right on the file system, you can do that. There usually is a button up here. I want to say maybe it's been a second since I've seen it, where you could actually get right into the operating system. But maybe they disabled that. Hold on one second. Anyway, when you get in here for the lab, please click around. One thing that's of particular importance, there's going to be a couple of cases as we move through labs where you're going to get to the bottom, like the middle of a notebook, and you're going to want to rerun all of the cells above that cell. And this is where you would say, oh, I want you to run all above. And you're just going to let the notebook run for like 50 cells. You say, Michael, why am I going to do that? Because you're going to have to re-download and rerun the data every time you get into a new lab environment. Now, just take my word for it. Just remember that under cell, there is a run all above. Okay. Just remember that I said that. Okay. So code blocks, here's some fun images. Like you can do things like to see how we can shell things out. Anyway, the main thing you need to worry about is that where is it a markdown block where it's just sharing text, and where is it a code block? Those are the main things you need to worry about, right? Heading, markdown, code, raw notebook conversion. Okay. In typical, you're going to run typically one cell at a time and kind of see the output. By the way, here's a command line escape inside of a notebook where you can see that it's actually just listing the directory. I cannot emphasize to you enough is that we do know that at least the ones that are in the solutions notebooks, when you pull them into the project notebooks, the solutions work. We do know that. We've run it end to end. We've seen it. It was even tested last week when I was teaching the class. This is not a Python class. If you're spending a lot of time troubleshooting Python, just be aware that our recommendation is going to be like, go back and check your steps and rerun the material in question, because we don't want you troubleshooting a lot of Python. And the other reason for that is that if this was a free form lab environment, I would totally love to dig in with you on the Python. I would. But these are going to be quick labs. They're going to be tightly controlled. We're not going to have a lot of flexibility. This is meant to show you what's inside the notebook and how it can run, not to teach you Python and not for you to do troubleshooting and debugging. There's actually a class for that. Okay. Not that I don't want to teach you that, but the lab environments are like I said, are brittle, and they're not going to support a lot of variation. So try not to go too far outside the guardrails, because it'll let you know that you've gone too far out. Okay. One other thing to note is that not today's lab, but lab tomorrow and the rest of the week, you're going to actually do a lot of this: file, download, and downloading a notebook file. I will remind you, there will be steps in the instructions, but as a general rule of thumb, you are going to download the notebook files when you are done with the lab. Not today's lab, but every day thereafter. If you forget to download that notebook file, we're going to have to grab somebody else's notebook file, or, some of them I have. I think I have like 2 out of the 3 actually, from last week. But you're going to have to have to like grab the notebook file, because you're going to be working out of that notebook file the entire time. Recommendation is that when you download your notebook file, by the way, give it a label like after lab 2 or after lab 3 or some variation thereof, and immediately email it to yourself, just so you can have a second copy, just in case your laptop or desktop goes belly up. That has happened also. But I'm going to remind you, but you're going to be downloading your notebook files after lab 1 today. Let's see. Anything else? I set the framework. I'm already logged in. Talked about running code. We're not going to talk about MD diff. We're not going to talk about widgets. Oh yeah. Other thing is that don't necessarily clear and restart your kernels. That's fairly apocalyptic in terms of like you just start the whole thing over. If you're going to start over from scratch, there's no issue with that, but just be careful about restarting and clearing all outputs. Okay. You veterans with Jupyter can help me support anybody else who's running into those things. That's it. It's just that simple. By the way, you can, underneath here, as we saw in the Sagemaker examples, there's so many notebooks, and you can download these notebooks anytime. Like if you want to create your own personal notebook library, nothing wrong with that. Let's see. No, no, I'm not gonna mess with that. Do note that this is a file system. So if there's directories in it, you can go down, in, out, down, and up. So you'll see that when we actually get to the labs. When you do an upload, by the way, so let's say I'm going to upload a file. Let me just, let's say I was going to upload my ML ops. Nope, that's CloudFormation. What was I thinking? Just note that when you hit upload, you do have to click upload again for it to function. And, it'll upload pretty quickly. Note that opening a notebook does typically take a second. Like that was actually pretty fast. Usually it takes a minute, right? This is the one about predicting airplane delays, by the way. Note that, once I'm here, I could just be like, hey, you know what? I just want you to run. Just run it all, right? And then literally what we'll do is it'll pop to the bottom. If I scroll to the top, you can actually see it should be running through things. There it is. So let's run that one. Let's run this one. Files are already downloaded. Here it's like checking this out. Here it's extracting a bunch of files. So notice that it should be running through all this. Where is it? Hold on. No, Jeffrey, it doesn't. Not that I'm aware of. I don't know that I've ever tried that either, actually. So it's, yeah. Are you not running now? Hold on. Because it doesn't look like, oh, now you're running. Okay, good. Good. There we go. Notice all the asterisks now. I didn't see those before. And I was like, what are you doing actually? Because I see the numbers, which was just history. And I was like, are you actually running? Because I don't see asterisks that show that you're pending. So as I scroll up in this, by the way, I'm just like, just making sure that everything is actually moving forward. But what it should be doing right now is it should be, running through everything. Huh, good. All right. And that is Sagemaker. Again, remember these run as virtual machines. Notice, by the way, the one that I started is now up and in service. It probably happened like minutes ago. The difference between Jupyter and Jupyter Lab, by the way, someone was asking me, is that Jupyter Lab opens up more like an IDE. So it opens up, like you can open up multiple notebooks in the same like interface, like they're like tabbed, almost like Visual Studio or IntelliJ or whatnot. If you click on Open Jupyter, it just gives you the file system and you open the notebooks in a tab in your browser, not in a single browser. So like here, it's opening up Jupyter Lab. And when I click on notebooks here, it's all going to open it up within the same browser tab, right? Yep, you keep waiting, right? So anytime if I had notebooks over here, if I clicked and open them, they would actually open in a different tab. So here's the launcher, but they would open up in different tabs inside the screen here. Huh, cool. All right. I am actually going to delete this. Why? Because why not? So first of all, I'm just going to stop it. So notice it says stopping. Same for the tutorial here. Just stop it. And then once it's stopped, you can actually go in and delete it, but it's going to ask you to stop it first. Okay. Let's come back over here. All right, so we were just doing a quick demo to create a Sagemaker notebook instance. Here's the deal. We just wanted to expose you to Sagemaker, right? The fact that it's a managed service, it has a bunch of different subservices and aspects to it, including ground truth, edge, a third-party marketplace, training jobs, inference jobs, like running in production, that kind of thing. You can use a built-in algorithm. You can write a script, right? Bring in your own algorithm if you want to in one of the existing frameworks. You can bring your own Docker container if you want to change the framework. And you can also use an algorithm from the third-party marketplace. Just know that if you change the framework, you have to bring your own Docker container. If you just want to bring your own algorithm or change the code or do some scripting, that's just some Python code. That didn't really even matter, right? And it does it in R, Python, and Julia. So all of that's good. If you're using the built-in algorithms, obviously that's good as well. We talked about the instance types, of which the T series and the M series are general purpose. I used the T's for test. You've got C for CPU. You've got R for RAM. And then you've got the P and the G series, which have GPUs built into the design of the virtual machines. All of the systems, but particularly the R's, the C's, the M's, and the T's, you can add GPUs to them using elastic inference. And remember that ground truth is for labeling, where you can supplement with a human workforce if unsupervised learning is not able to actually categorize the components in question. And then, you've seen the Jupyter notebooks, which allows you basically to run code and markdown as you run down. And we also talked about deployment options for either online and batch. So you can either do single data points or a data set. Any questions there? Okay. Let's talk about lab 1 then. So lab 1, estimated completion time is going to be 60 minutes. That sounds right. It's 2 o'clock now. So here's what you're going to do is you're going to launch an Amazon SageMaker notebook instance. You're going to launch the notebook. You're going to run code in the notebook. You're going to play around with the notebook. You're going to run a lab. So this is a hands-on experience with your own notebook. This is what this is going to look like. Okay. Assuming that Michael can get it. What you're going to do is you're going to go to webage.quicklabs.com and you're going to get logged in. So I'm going to put the link in the chat. Please bookmark that. That's where all the labs are going to be conducted. And remember, you're going to get a different lab environment every single time. Now, right now, there are 25 pre-warmed and ready labs in the environment. And I believe there are 21 of you. Let's see. Yeah, 21. Okay, cool. All right, there's 21 of you. So you're going to get logged in. You're going to click on My Learnings. You're going to click on the machine learning password. And here's what I want to do for my own peace of mind. The minute you are inside the lab and you can see this page and you've hit the start button, can you please give me a green checkbox? It's under reactions, by the way. You might have to click on more to see it. Here's mine. Once you are there, please log into your AWS account. Once you've already clicked go on the start lab, please log into the AWS account. It should start up pretty rapidly. Do know that if you come back later and we're not doing it, then just know that you're going to have to wait about 10 or 15 minutes for provisioning to finish. Okay. But please click the green checkbox and let me know when you've gotten logged in. Otherwise, I'm assuming you're having problems. And once you're there, go ahead and launch your SageMaker notebook instance. You're going to follow the directions specified. So you're just going to scroll down, read the lab overview. It's going to take you about 60 minutes. You're going to start the lab. Everything you need as far as like S3 buckets and everything else is going to be on the left-hand side underneath these instructions. So like I just clicked on Start Lab. See all these instructions that are now over here? And the instructions say things like open your lab by choosing Open Console. That's how you're going to get logged into your AWS account. Make sure when you follow these instructions, you get very detail oriented. If you miscapitalize or misspell something, sometimes it's not going to work. So you see how it says ML Dev Notebook here? That's meant to be copied. Sometimes if you spell that wrong, the lab won't go forward. That's a security problem with Quick Labs. That's not an AWS problem per se. Okay. Notice the region is US West 2. Here's the lab bucket. Here's the SageMaker roll arm. So yeah. Okay. Not going anywhere. I'm here to answer questions, but hopefully you've started your lab. You're getting logged in. Okay, so it's 2:06 right now. We're going to check back in at 3:15. So please sneak a break in there. If you're done early, mess around a little bit in there. Don't worry, you'll run into some security limitations, but examine the notebook, run other things, kick things in the markdown language, try to open up a terminal, do all your stuff. All right. Otherwise, at 3:15, we're going to check back in. I'm not going to go anywhere. I'll have my headset on the entire time. I might step away towards the latter part for about 10 or 15 minutes, but I'm definitely going to be here for the bulk of your lab navigation. Okay. Take a breath, be patient, make sure you're reading what you're doing. Yeah, just have a little fun with it. Okay. I'm here. Let me know. By the way, also a reminder that this is not graded in any way, shape, or form. This is totally for your fun and your learning. Okay. And by the way, if it goes horribly wrong, you're going to learn a lot. I promise you. Okay. So just keep going. let's see, Spencer, you were asking like, what's the worst case duration for notebook instance provisioning? The worst case instance is that the browser for the console does not refresh exceptionally well. So usually at most, and it depends on the size of the instance and what you've done with the lifecycle configuration, but typically it's no more than like 5 minutes. So you might want to refresh the console, like either inside the console or just refresh the browser and see if that makes a difference. The console is horrible about refreshing. You think it's like, why is this taking 20 minutes? And it's been done for like 15. Now, there are cases because it is shared infrastructure that it takes longer than 5 minutes, but those are certainly outliers. Usually it's way faster than that. So yeah, it's shared infrastructure. So, but typically within 5 minutes. One of the things that's a little confusing, I just have to say this, and I already wrote Amazon about this. I was like, why are you using M4s? Just so you know, M4s are older and like way older. So that's on older hardware. So I have asked them to update the sizes in there because they should be on M5s at least, if not M6s. Good time to take a break, by the way, whenever you do something like that. Just walk away. If you watch it, it's like watching paint dry. Go slower.